Okay. On page 99 in Chapter 8, Dilutions of the 4th edition textbook, we have a hemocytometer question. So what the question is here is we have a blood sample is diluted 1 in 100, and then 4 W areas are counted on the Neubauer hemocytometer. A total of 50 cells are counted. What is the white blood cell count? So we need some information to kind of determine how we're going to go about solving this. So first, let's determine what information we have and where we need to go further with it. So what we can see is by stating that the 50 cells are counted, what we've determined is that we're counting those cells from a diluted sample. Okay, so we've been given the final concentration of 50 cells. What we're determining the white blood cell count is essentially the original concentration, because if you remember from this question, 50 cells in this sample have been diluted 1 in 100 times. Okay, so let's put information where it's needed. So we've determined what the white blood cell count means, is that is originally our original concentration. Okay, so we don't know that. We're determining that. So original concentration equals X. Okay, our dilution, we've been told, is 1 in 100, and our final concentration is 50 cells in those 4 W areas. Okay, so when it says those 4 W areas, what does that mean? Okay, so I've included a Neubauer hemocytometer picture here. So what you can see is that we have been told, we've got this picture right here, that each one of these spaces is essentially a volume. So in this space here, this is 1 millimeter, okay? And in this space from here, this is also 1 millimeter, because you can see that the total space here is 3 millimeters. So we can divide that into those 3 spaces. So when we're looking here, those 4 W areas, and we can write it like 4 times, and what we said was 1 millimeter. And again, we determined this space was 1 millimeter as well. And then, as you can see from the figure 8.4 on page 98, it's also determined the depth of this W location, which is 0.1 millimeters. Okay, 0.1 millimeters. All right, so our actual final concentration is those 50 cells in that 4 times 1 millimeter times 1 millimeter times 0.1 millimeter. Now, because this is hard to write out every time, let's just go ahead and simplify the denominator equation, this piece right here, into one single answer. Okay, so 4 times 1 millimeter times 1 millimeter times 0.1 millimeter gives us 0.4 millimeters cubed. And the reason why we're saying cubed is because we've got 1, 2, and 3. So then the final concentration then becomes 0.4 millimeters cubed. Okay, so if we remember from the original concentration, that actual equation, it's original concentration times dilution equals final concentration. Like so. So let's put that into the equation. Okay, so our original concentration is X, or we can also just call it original concentration. And because it's times dilution equals final concentration, what we need to do is divide the dilution by itself to isolate the original concentration into the only thing that's on the left side of the equation. So then that becomes 50 over 0.4 millimeters cubed divided by, and our dilution is 1 over 100, 1 over 100, okay? And if you remember when dealing with fractions, when we divide fractions by themselves, what we do is we actually switch the numerator and denominator on the one that we're adding into it. So 50 over 0.4 divided by 1 over 10 then becomes 50 over 0.4 multiplied by 100 over 1. Okay, so the original concentration equation then looks like this. times 100, which is our dilution, over 1. So then we've got here, which equals 0.4 millimeters cubed. Okay. All right. Now, because this is actually, we can simplify this even further. 5,000 over 0.4. 0.4 actually goes into 5,000, 12,500 times. So we can simplify this into 12,500 cells in 1 millimeter cubed. Okay, and again, that's because we did this. We went 5,000 divided by 0.4. So 0.4 goes into 5,000, 12,500 times, and 0.4 goes into 0.4 one time. Okay, and that's how we resulted in this value here. Now, on the next page, on page 100, you can see that it says that most labs report white blood cell counts in cells per liter, not in per millimeter cubed. So what we can do is change this using conversion factors. And if you remember that 1 cc equals 1 mil, we can use the nice conversion factors. If you remember, there are 1,000 microliters in 1 milliliter and 1,000 milliliters in 1 liter. So we can use this information to then extrapolate going into per liter. So you can see here that we've got 1 millimeter because there are 1,000 millimeters in a centimeter type thing. We've got that factored. If remembering, we've got cc's and mLs are equal to one another. Okay. Microliter. And then we've got microliters into liters. We could have put another conversion factor in here using the milliliters as well, but rather than having two, we've just simplified it so that we've got right like that. So then that becomes just like we've got right here, which is a very large number per 1 liter. And let's make sure we set up our equation correctly and get rid of all the matching things that are in the numerator and denominator position. So we can see that we set everything up correctly, cells per liter. So we've done this equation correctly. Now again, because this is very hard to report and it just takes a long time to write it out, we can simplify it. You wouldn't be wrong to leave it as it is, but there's nothing wrong with simplifying it into 1.25. Actually, let's just put this here first. Sorry about that. Times 10 to the 10th power cells per liter. And that's how we go about doing that question. And you can see here, and the reason why it's an exponent of 10 is because we moved 3, 6, 9, and then 10 spots right there. Okay, so our final answer is 1.25 times 10 to the 10th power cells per liter, and that's how you determine that overall question. So remember, we needed to know our equation, original concentration times dilution equals final concentration. We needed to know the information for the W's, okay, and we have that, been given that here, which is reported just like this. So anytime you're writing a value or been given how many cells are in a W area, when you do all four of those locations, you've got 4 times this area right here, because we said this is 1 millimeter, this is 1 millimeter, and the depth of each W area is 0.1 millimeters. And that's how we came up with a total of 0.4 millimeters cubed.